Chapter 2 Review for Test. Number 1, when we read the problem, we're going to write our given or find and rearrange the equation to solve for the unknown in terms of the known. So number 1, it says a baseball pitcher throws a fastball at 42 meters per second. So in my given, I know that V is 42 meters per second. From the pitcher, if the batter is 18 meters from the pitcher, so X is equal to 18. If you're not sure what something is, you look at the unit. Meters per second as velocity, and then we see this as meters, and I want to find the time. How do I know I want to find? It says how much time. So my basic equation is V is equal to X over T. But we want to rearrange the equation to solve for the unknown in terms of the known. So first, I'll multiply both sides by T. And then I'm going to divide by, I'm solving for T, so I'll divide by V. So I'll have T is equal to X over V. So it's 18 meters divided by 42 meters per second. And that comes out to 0.43 seconds. But in physics, we always have a foolproof way to check our work every single time. So I have a meter divided by a meter per second, which is a meter times a second over a meter. So these cancel, and I end up with seconds, which is the correct unit for time. Okay, number 2. The average velocity of an object during 6 seconds, so T is equal to 6 seconds, is 2 meters per second. So V is 2 meters per second. What is the total distance? So I want to find X. So our basic equation is V is X over T. So X is equal to V times T. So it's equal to 2 meters per second times 6 seconds. So this cancels with that, my seconds, and I end up with meters, which is the correct unit. So this comes out to be 12. Number 3, the average speed of a plane was 600. So I'm given V is equal to 600 kilometers per hour. How long, so that means I want to find the time. How long did it take the plane to travel 120 kilometers? So we know that V is equal to X over T. So T is X over V. So 120 kilometers divided by 600 kilometers per hour. And our calculator, T comes out to be 0.2 hours. Again, I can cancel my units. This cancels with this. And 1 over an hour is an hour. Okay. Let's do number 4. So number 4 says, a car starting from rest travels a distance of 3.6 meters in 1.6 seconds. So we're given X is equal to 3.6 meters and T is equal to 1.8 seconds. Find the average speed. So V is equal to X over T. 3.6 meters over 1.8 seconds would be 2 meters per second. Number 5, a moving body must undergo a change of position. Number 6, a race car starting from rest accelerates. So now this is one of the problems where I'm looking at my equations for acceleration. So if it starts from rest, that's one of my hidden variables. So the initial velocity is equal to 0, because that means starting from rest. it accelerates, so A is 4.90 meters per second squared. Again, we read, we write, we read, we write. What is the car's speed? So I want to find VF after it has traveled 200 meters. So X is equal to 200 meters. So now we're doing our systematic approach to problem solving. This is what I'm given. This is what I want to find. So I'm given VI, A, and X, and I want to find VF. So I look at my blue sheet, and I say which equation has those four variables. So that's the equation VF squared is equal to VI squared plus 2AX. So VF is equal to the square root of 0 squared. And again, remember I told you whenever something is 0, we go like this, so that whole term goes to 0, so I don't have to bother writing like 0 squared. It makes it easier. So plus 2 times 4.9 meters per second squared times 200 meters. Now again, you don't want to forget that square root sign. So when we do it on our calculator, it comes out to be 44.3 meters per second. Again, if I look at my units, because in physics we have a foolproof way to check our work every single time, underneath the radical, I have a meter per second squared times a meter, which is a meter squared over a second squared. And when I take the square root of the number, I take the square root of the unit. So meters per second is my correct unit for velocity. So I see I did not make a mistake. Okay, let's go on to number 7. So number 7 says a car, and we're going to do our given and our find because we want to do our systematic approach to problem solving. A car initially traveling east with a speed of 5 meters per second, so VI is 5 meters per second, and again this is east, is accelerated uniformly, so A is 2.0 meters per second squared east for 10 seconds along a straight line. How far during this 10-second interval the car travels a total distance of X. So this is our given. This is what we want to find. So we're given VI, A, T, and X. Those are my 4 variables. Okay. So now I'm going to say which equation has those 4 variables. So X is equal to VIT plus 1/2 AT squared. So I substitute in 5.0 meters per second times 10 seconds plus 1/2 2.0 meters per second squared times 10 seconds squared. And I don't want to forget that part. I'll have to move this over so we can see it. So X comes out to be, this part is 50 plus 10 squared is 100 times 2 is 200 divided by 2 is 100. Remember, you always can use mental math. So it's 150, but when I look at the answer choices, it only has them in correct significant figures, and that's why we have to be able to recognize correct significant figures. So with 2 significant figures, it's 1.5 times 10 to the 2 meters. Because if this is 2, so this is our answer for number 7. All right, let's look at number 8. So number 8 says a child is riding a bicycle at 15 meters per second. So VI is equal to, and this is number 8, 15 meters per second. accelerate. So the acceleration is negative 3.0 meters per second squared for 4 seconds. What is the child's speed at the end of this interval? So I want to find VF. So again, for us to know which equation to use, this is what I'm given. This is what I want to find. So I have VI, AT, and VF. I look at my blue sheet and I say which equation has those 4 variables. So that's VF is equal to VI plus AT. I substitute in 15 meters per second plus negative 3.0 meters per second squared times 4 seconds. So VF comes out to be 15 plus negative 12. So it comes out to be 3 meters per second. Okay, number 9. It says a car is driven south, so I should know what all my directions are. So I have north, south, east, and west. So a car is driven south, so the car is driving this way with a decreasing speed. The acceleration in the car will, if this is my maximum speed, and as it's going this way, this would be my minimum because it's slowing down, then I would know that my acceleration is going in the opposite direction to cause it to slow down. So opposite of south would be north. Number 10, a locomotive starts from rest and accelerates at 0.12 meters per second squared to a speed of 2 meters per second in 20 seconds. This could be described as, so we know it's accelerating, okay? It starts from rest. So starting from rest, we know the velocity is increasing, okay? Because it's going from 0 to 2.4 meters per second. So that's how we know the velocity is increasing, and they told us it's accelerating. So what we're going to do is, on this one, we know that it's a constant acceleration. So we're going to cross this off and cross this off. And then the velocity is not constant because it's increasing. So we know the only answer left is A. Number 11, which is constant for a freely falling object? Well, for something that's free falling, the velocity changes because it could start from rest and the velocity is going to increase. The displacement is going to change and the speed's going to change. So the only thing that's constant is the acceleration due to gravity that we call little g. That's going to be the same. So the answer there is D. The distance time graph represents the motion of a laboratory cart. According to this graph, the cart is, so on a distance versus time graph, the slope is the speed. So this is a straight line. On a straight line, everywhere on the line, the slope is the same. So if I took any 2 points on this line, I'm going to have the same slope. So that means that the slope is constant. So the answer is moving at a constant speed, just like the lab we did with the constant speed cars. And we drew a graph and it looked just like that. So the answer to number 12 is A. Okay, let's turn the page. Number 13. The graph below represents the motion of a body moving along a straight line. According to the graph, which quantity related to the motion of the body is constant? So this is a velocity versus time graph. On a velocity versus time graph, the slope is acceleration. Well, this is a straight line, and on this straight line, we know that this is constant, and we know that that represents the acceleration, so the answer to number 13 is going to be a constant acceleration B. Number 14. The graph below shows the relationship between the speed and the elapsed time for an object falling freely, so this is free fall, from rest near the surface of a planet. What is the total distance the object falls? On a speed versus time graph, the distance is the area under the curve. So the area under the curve, what we're going to do is we are going to look, it says for the first 3 seconds, here's 0, here's 3, this is my curve, so my area goes down here, this is my area, and this shape is a triangle. So the area of the triangle is 1/2 base times height. So 1/2 the base, which is 3, times the height, which is 8. So 3 times 8 is 24 divided by 2. So the area is equal to 12 meters, which is how far it went. And then the last problem is a free fall. It says an object starts from rest, falls freely. So for this one, we're going to do it just like we did our homework. So we're going to write our given. And I'm going to draw a picture. Here's the object falling to the ground. The initial velocity is 0. Here's the maximum velocity just before it hits the ground. And when I read the problem, it says, what is the velocity? So I want to find VF after 3 seconds. So I'm looking at this problem and I say 1, 2, 3, I'm missing something. So we forgot our hidden variables. We need the acceleration due to gravity, which is negative 9.8 meters per second squared. So I have VI, I have T, I have little g, and I want to find VF. So these are the same kinematic equations, but for free fall, whenever I have an A, it becomes a G, and then wherever I have an X, it becomes a Y. Which I don't even need here because I'm not solving for that. So the equation is VF is equal to VI plus GT instead of A. So VF is equal, and remember that goes to 0. So it's just going to be negative 9.8 meters per second squared times 3 seconds. So when I do it on my calculator, it comes out to be 29.4 meters per second, which is choice B. So I do all my problems the same way. I write my given, I write my find, I look at the 4 variables whenever there's something that's accelerating, I make sure I put down any of the hidden variables, and then that's how I know which equation that I'm going to use to solve the problem. And that's it.